Hello everyone and welcome to my new video. And what is this video about? Well, I'm here in Max. I'm going to make a Max patch and particularly focusing on an object called the function object. What is the function object? Well, if you create one, you're presented with this charming grey rectangle. But if you lock the patch and click on it, you can make these, you can draw these things in. This is a breakpoint function generator or an envelope generator, a multi-stage envelope generator. I can trigger this and it's going to go through all of these points and spit them out as data in various forms, such as lists, or what's that? An interpolated Y float for X input. Interesting. We can also send everything out as a list here and other things, but I'm primarily interested in this second outlet, which sends all points in the line format. So if I was to create an easy DAC to turn on the DSP, and then I create a line object, line tilde object, give it initial value of 0, plug that into the line, and then connect a live scope to the output of line, and then bang the function, and let's see what it does. Whoa, okay. So it just spat out that envelope in a DSP signal, an MSP signal, if you will. So I can create a clear message somewhere. There we go, clear. And I can start again. So if I was to just draw a ramp up like that, trigger that, it's going to go ramp up and then come to an end. I can change that around like that, trigger that, and it's going to ramp, come back down and stop. So this is pretty interesting. So, you know, you might want to use this for, like you would most envelopes, to do modulation of another source, whether that's amplitude modulation or pitch modulation. For example, if I was to create a cycle object that was oscillating at 200 Hertz and I connected that to a multiplier, let's maybe move this over here. And I connect the line to the multiplier and the multiplier to the speaker and trigger this. It just ramps it up and ramps it back down. So we're all kind of familiar with that. That's all nice. Let's clear that, and we could maybe do like a multi-stage thing like this. Well, yeah. But I'm not interested in that. I actually want to experiment with using this as a way to read back samples from buffers and see what I can do with that. So that's what I'm going to do. The first thing I'm going to do is delete this. And I'm going to go to the mode. There's a mode attribute. Where is it? Mode. We have different modes, linear and curve. I want curve. I'm going to swap the line object out for a curve tilde. And then what I can do is I can apply curves to the envelopes. Let's make everything just a touch bigger because we've got some space. So if I hold Alt, I can apply a curve like that. This is very exciting. We can carve in some nice toothy functions. And then when we trigger that, we get the curves as an audio signal. So that's very exciting. Right. What can we do? Well, first of all, let's make a buffer. Let's make a buffer and let's call the buffer Buffy. And let's create a wave object. Wave tilde, referencing the Buffy buffer, 0 start point, 0 end point, and 2 channels. All right. So I'm going to use the function to read through the wave tilde object. Now the wave tilde object wants a signal of 0 to 1 in order to access the table position. The table being the sample that I'm going to load in the buffer. Why don't we make a waveform object with @buffer_name, if I can spell it right, @buffer_name Buffy. And then when I load a sound in there, we'll be able to see that it's actually worked. And I did prepare a little drum loop earlier in Ableton, so I'm just going to drop that in the buffer. There it is. Okay. So if I was to say use a phaser, let's just create a quick live gain here so we can keep an eye on our levels. Let's turn that down, connect that to the speaker. So if I was to pull in, say, a phaser, I could use the phaser. God, this is already getting very messy. I could use the phaser to read through the wavetable position. So let's just do that to start with. Let's make a phaser and let's say phase at 1N at lock 1. And then I'll just very quickly create a transport, turn the transport on, and then have a look at what the phaser is doing. So when I start the transport, the phaser is ramping from 0 to 1. And if I plug that straight into the wave and turn that up, all right. It's reading through our sample. So I want to put the tempo to 100 because that was the tempo I did the original loop at. Some generic lo-fi thing I made with a preset in Ableton about half an hour ago. Right, so we've seen that we can use the phaser to read through the wavetable in order to play back the sample. But I want to use this function generator to do that in conjunction with using this curve object. So if I was to delete the phaser, goodbye phaser, and just quickly have a look at some few things in the inspector. So by default, the function should have a range of 0 to 1 on the y-axis. So top to bottom is 0 to 1. And then on the x-axis is the domain, which currently is 1000 milliseconds. We'll get to that later. So by default, the x range is from 0 to 1, which is perfect. So as the function moves through these various stages, it's going from 0 here to 1 here, and then in between. So I can pretty much plug the curve into the wave, fire off this envelope, give myself a bit of volume here, fire off this envelope, and it's just done that. Okay, so that's kind of fun. So if I was to just draw a straight line like this and fire that off. Okay. So because that's a second, it's reading through over the course of a second. I don't want to work in this domain in milliseconds. So I'm going to change the domain to let's have a think. Goodness me. Domain. Let's change the domain to 1 second. Let's clear the envelope and let's see what. So that's really, 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 really fast. But if I do like a curve like this, no. So the domain is, okay, no, I haven't thought this through. Let's go into the inspector. High domain x-axis 1. Yeah, interesting. Horizontal grid step, vertical grid step. Okay, so that's a bit fast. Okay, so I need to think. Use your brain. I'll just drink some beer. That'll help. It won't help. It'll make things worse. Okay, so obviously that is 1 millisecond, which is incredibly fast. But I don't actually want to trigger this. I don't want to trigger this. I actually want to use another ramp, like another phaser, to read through this. And I was thinking as I was trying, I don't really know if it's possible. And I was looking at Ableton's Shaper object in Max for Live, which handles this very, very, very well, using a phaser to drive the function. But there were too many sophisticated sub patches in there, including various list processes using ZL objects and some very clever calculations of bars, beats and units to ticks and stuff like that. All a little bit much for my brain. And to be quite honest, because it's Valentine's Day, I couldn't really imagine anything more unattractive than reverse engineering a list process. I don't know. Maybe you like lists. I think they're a bit boring personally. Anyway, so what I'm going to do is I'm going to try and use a phaser. So if I connect a float, let's just disconnect this temporarily. If I connect a float into the leftmost inlet and a float to the leftmost outlet, and I read through with this float, you can see how this number is being updated according to where we are in the function. So I'm currently at 0.85 through the function, and the value, which would be on the x-axis, so the value at this point is 0.198. If I was to go to 0.99, you'll see we're somewhere around here. If I went to 1, then we're at 1. And if I maybe try that again, you can see how that's gone down because I've moved that point. So I want to use something to kind of drive that float. Well, let's try a phaser. Let's make a phaser here. And let's say phaser go at 1N. Actually, let's go 1.0.0 at lock 1 and see if that's ramping. Yeah, okay. Let's take a snapshot of that every millisecond. Connect the phaser to the snapshot, and then let's connect the snapshot to, oh my goodness me, connect the snapshot to the float. And yeah, we're getting a readout of our function here in a float format. So if I was to maybe put that into a sig object, and let's see if that sig is responding. It is, right. Yeah, okay, let's draw in a couple more points here just so that we can, okay, that's working. Right, let's delete that curve and connect the sig straight to the wave and see what we get. Oh my goodness me. Yeah, we've just hit late 90s, mid-period Autechre when they were just starting to go very experimental. Okay, so we got some problem there. We got some glitch, and it's not the cool glitch, it's the bad glitch. So we need to do something about that. Let's try and use a ramp smooth. Let's connect this object. Let's make a ramp smooth, ramp up 100 samples. Let's try 100 samples and down 100 samples. Yeah, okay, that's a little bit better. So why am I doing this? You might be thinking that's not music, and no, it isn't. But like, I was kind of thinking about, whilst I was playing around with this, of like, you can actually get some very interesting off the grid, perfectly cycling rhythms by doing it in this method, because you can sync your phaser to the transport. It's currently going at 1 bar at 100 BPM, and it's reading through perfectly this function, you know, on that kind of timeline. So, but things are going to get more interesting when we start introducing the snapping. So let's just have another little listen to what this is doing. Let's clear it, and if we just drew a straight line like that. So the way that you've got to think about it is the x-axis is time and the y-axis is position in the sample. So from going down here to here, we're ramping through the sample. If I put a breakpoint roughly halfway and then pull this breakpoint down, it's going to go halfway forwards and then come back halfway backwards to the start. And if I put like, if I put some curves in here, it does it in sort of. Okay, so we can get some really sort of interesting, unusual rhythms. But now what I want to look at is the snapping. So let's right click the left inlet and look for the snap to grid attribute. Lock the patch, click that. We want to go snap to grid on the horizontal and vertical axis, but there's no grid. So we need to show the grid, display grid on the horizontal and vertical axis. Okay, now we've got a grid, but the grid is not right. That is not right. So why is that? Because yes, let's display grid. Should have worked this all out earlier. Doesn't make for a punchy video. Low and high display range, 0 and 1. Ah, that's useful, but that's not what I need. What could it be? 1 there. Ah, okay, let's go. No, that has to stay at 1. I need to split the grid up. Vertical grid step. Ah, okay. Yes. Vertical grid step. Horizontal grid step. 1. Okay, so now we have a grid step of 1. So this is good. We're working in a range of 0 to 1. So if I wanted to split this into smaller chunks, I'm going to need to divide stuff by 1, I think. So if I do a little bit of maths down here, so if I do divide by 1, and I put a float in here and put a float here, and I say 16 divided by 1. Why didn't that work? Oh, wait a minute. No, that's not right. It needs to be, my bad, it needs to be 1 divided by 16, or whatever number I want to divide by. Yeah, okay, so if I do 1 divided by 16, then we get this really, really tiny number of 0.0625. So if I was to use that number to divide my grid, then I'm splitting 0 to 1 into musical equal measures, which will work against me ramping through it to access a 1-bar drum loop. If we imagine that the 1-bar drum loop is one lot of 16th notes, then if I split 1 into 16, we can jump to those different positions. So what would be an interesting way to patch this to make it nice? I guess we could do, well, I guess I could just plug that straight in there like that and just say 1. Okay, it's already done it. It's already created a nice, perfect grid here on, surprisingly, the x-axis and the y-axis. But I only wanted it on the X, but it's done. Let's have a look at the Y. Where was it? Vertical grid step 0.1. So that would actually, what would this be if it was 0.5? Okay, so that's, what about if we did the same for that one as well? Let's try this 1. Okay, now we've got a grid of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm pretty certain that's 16 by 16. So, and we're snapping to the grid now. So I can go to, say, from the kick to the snare and back again like this. And we'll go to the first snare, I think, and then back, and then let's just have a listen. Let's see. Yeah. So I could maybe do something like repeat that. I could maybe go, let's see what this is like. So this would be 1, 2, 3, and then we can kind of repeat that like this maybe, and maybe do this kind of like syncopated type thing. Ha! Not remember. Okay, so the reason why it's speeding up is because like going by a factor, I don't know if you can see here, but like these are all perfectly sitting. I've just accidentally created a sustain there. These are all perfectly sitting on the beat because we've snapped the grid into 16th notes. Whereas this, you can see they're slightly not. So I would actually have to come down here like that in order to make the ramp play. So you can see the output of the ramp here. So if I speed, and because we're using a phaser, if I was to speed up the tempo, it'll speed up the reading of the function. So if I go, okay. Oh, I went down to 10 BPM. Interesting. So let's clear that, and let's maybe start to, let's turn the audio down. Let's maybe start to think about how we can make a wibbly wobbly wabbly wobbly blue sort of drum beat. So let's first split this up into sections, something along these lines. We can actually also make the points much bigger, which I quite like. The point size, let's maybe put that, oh my goodness me, yeah, that'll do. Yeah. Okay, so now I've split my loop up into 4 bits. Let's fire off our loop. So I can sort of break this down into little bits now, and maybe let's put a little curve here. And then maybe here as well. And so you can see how I'm adding these little extra curves, and it's kind of like sort of modulating the playback ramp to get these sort of scratchy sounds. But because it's snapped to the grid, then we can jump to those specific points in the loop, like very, very nicely. If we want, we could come backwards, like something like this. Oh. Those point sizes are a bit big. I've decided there. Can't see what I'm doing. Okay, that actually sounds kind of bad. So very quickly you can kind of ruin the loop, but you know, it's okay. Let's go with that idea again though. Let's break it down into equal bits and maybe just try something like this. Yeah. Yeah. Fun. Add some more points in here. Yeah. So it's still in time, which is kind of nice because the start points are snapped to where we would be at that point in the sample. Does this make sense? Leave a comment if it does, or if it doesn't. But if it doesn't make sense, I'm sorry, it's too late. The video will be over. Yeah. So, you know, this is obviously a very, very great way to clear a dance floor. It's the type of music I like to make. So, yeah, there's just lots of fun here to be had. And, yeah, using this ramp-based approach. I'm mad into ramps right now. I just think if you can use a phaser to do anything in Max, then you're just going to get really good results, in my opinion. The ramp smooth obviously just does a little bit of interpolation between smooth and incoming signal. Smooth incoming signal across n samples each time an incoming value changes. It begins a linear ramp to reach this value. So that it's pretty clear that it's just doing some smoothing between signals, which can give you just a better signal, especially when working with samples. I mean, if we remind ourselves what that was like without that, really bad, really bad. But with the ramp smooth, we can just kind of, and I think in this context, because we're kind of doing sort of destructive stuff to samples, like real-time destruction, then I think that kind of quality doesn't really matter. If you want to play a drum loop in its original fidelity from start to finish, then you would probably want to find a more accurate, sample-accurate way of doing that. But this is pitch modulation, so beat-based pitch modulation. Let's just go all the way backwards. So yeah, I mean, if I was to just say do something like this. Oh, sorry about the clicks. Let's maybe get rid of those clicks. And then if I was to do sort of something like this, then really all I'm doing is just repeating that part of the drum loop, because it's going to create a phaser ramp. I mean, it's not a phaser, but it's creating a ramp that's just going to play around that part of the sample, which is going to be beat 3 of 16. So then we're just going to get that. So if you kind of work in this sort of straight linear fashion like this, you can kind of, I mean, I wouldn't recommend anyone do this, but you can kind of create like little drum patterns, I suppose. Let's see what this sounds like. Yeah. Oh, I've ruined it. Oh, that's good. Sorry about the clicks. That's really bad. So yeah, if I was to go something like here and then come back again, and then maybe go from something like here. You kind of do these sort of yeah, find these interesting sounds, or you could just kind of do just really kind of drastic sort of tape stop type things like this. Oh no, that would probably be more like this, I suppose. Yeah. Let's just make something really silly. Let's just draw in a load of points like this and just do something like this. Or the curve, holding Alt and drawing the curves is sort of what gives it that sort of inertia. It's a bit much, isn't it? You know what we could actually also do is because we're working in signals here, we could actually kind of use some maths to kind of attenuate this. So I wonder, I guess let's maybe do it before the ramp smooth. I'll just move all of these down a little bit. If we go into down here before the ramp smooth, I mean, we could use like a multiplier here to bring the signal down a little bit, just to decrease the modulation a little bit. So if I turn this up, we're going to get nothing. But if I increase this, so you can see it's very, very slight, but only a tiny little bit of signal is coming through. You can see it's happening there. So if I maybe went to 0.1, and then we could even add to jump to a different position. Let's make an add tilde. Put that in there. Go on, get in there. Oh, get in there. All right. And then connect that to the scope and then add the signal. Add to that signal. We can move to a different point in the... Yeah. It kind of sounds bad, but like it's just that we go for like a really small number here, like 0.0125. Go to point and then add 0.5. We're now scratching halfway through the sample. Okay, I'll just put 1 in here so that loads like that by not a comma. Okay, there we go. So I could maybe put a comment in here, amp, and then this could be like offset. Command J to justify those comments. So yeah, that was kind of it really. Just sort of fun screwing around with loops, but somehow using this pitch modulation or potch modulation to modulate drum loops, but somehow do it in a way that's retains a little bit of musicality, albeit in a very abstract way. So, you know, stuff like this. Yeah. Okay, I think that'll do. So let's just do a quick summary. What have we done? We've made a function object and then we've created the grid. The grid is divided into 16 bits and then it's got a range of 0 to 1 on the X and Y axis. We're then going into a signal to generate we're using a phaser to read through the function, which then comes out as a float, then gets converted to a signal, and then the signal gets smoothed and then gets used to read through the sample, which is being referenced by this wave object to this buffer, which contains the sample and some other stuff and live scopes and stuff. So there you go. I'm going to go and put this on my Patreon now, where if you would like to support me there, you can download this patch plus all kinds of other things to do with Max and Ableton Live, and you can do other things. And maybe I'll put this in Max for Live so you can work in Ableton or something. I don't know. Maybe that might be another time because it's a bit late now. I'm a bit tired. But anyway, I had fun. Okay, see you next time. Happy patching.